Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And and a very warm welcome to this live session on gravitation. So up until now, whatever we have seen is like how does this gravitation vary with region? If you remember, if we were at a height, if we were at some depth inside the earth, then the gravitation was varying with like the distance from the surface of the earth. And similarly, we saw that once you're at North Pole, once you're at South Pole, or once you're at Equator, you're experiencing different kind of gravitational field and acceleration. So it's the net effective acceleration still is going to be the same, but also due to the variation in the radius, rotation of the Earth, etc. So up until now, we have understood that with variation in region, you're going to experience different gravitational acceleration. So if you had been dropping a ball from a height, you'll be observing that these balls are coming down at different time and different regions. Right? So today we are going to get into something even more interesting. So think about your celestial bodies. How do they behave as a system of masses? Is there any mystery behind them, and how does this all work? And do masses also have some potential like your charges, or like let's say like the one that you see on your battery? Do they create a potential difference? So today's lecture is going to be even more interesting. So stay tuned and do not forget to like and share this video, and also do definitely subscribe to this channel and click on that bell notification, guys, so that way you'll be able to get timely updates on all the classes happening on JEE English. And students, that being said, I'm Muralidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And I have filed 25 patent applications on the state-of-the-art technology in India and abroad, US and so yes, today we are going to get into even more interesting thing that is going to be your gravitational potential. But before that, let me inform you and let me shortly take you through a complete package for your JEE Mains and JEE Advanced preparation. So it's going to be an Unacademy subscription. What do we have on an Unacademy subscription? We have the best educators across the nation aggregated on one platform. That is going to be an Unacademy subscription where you are getting daily live interactive classes with these best educators on a very interactive platforms with polls and leaderboards where your learning becomes super fun and also very competitive, and it's a way of learning. And not only that, on an Unacademy subscription platform we have active test series going on, national level active test series going on. So this way you will be able to learn from your mistakes, you will be able to assess your ranking and even more. Hi. Yeah. We will get started with one shots as well. Okay, one shots we'll do it along with PYQs, so that way you have a perfect understanding of your syllabus. So we'll be soon ending the PYQs. Absolutely, Abhishek. Hi. And not only that, on an Unacademy subscription platform, definitely. Yeah, Abhishek. Absolutely. And not only that, every program on an Unacademy subscription is a structured program and a very systematic program. You don't have to worry about your schedule. Everything is planned. So each program comes with like live doubt clearing classes. So every 4th class is going to be a doubt clearing class. Along with that comes a bunch of quizzes and mega quizzes. So yes, that is the beauty of Unacademy subscription. Not only that, one more amazing thing about Unacademy subscription is all you have to get is one subscription and you'll get unlimited access throughout the period. And how do you avail this Unacademy subscription? First of all, download Unacademy Learning app, click on the left hand top corner extension bar after logging in, and then choose plus, and then choose IIT JEE as your goal, and then hit on this get subscription button. Right? Once you hit on this get subscription button, you will realize that you're going to get unlimited access throughout the period. And you'll get access to both JEE Mains and JEE Advanced, no batch restrictions. So as many programs as you want, you can access on an Unacademy subscription platform. And absolutely, Abhishek, absolutely. And one more important thing, students, coming to the pricing, an Unacademy subscription is quite economical. If you have a look at a package of 24 month on the plus subscription, it's going to cost you only 50,400, which is going to be less than 70 rupees a day. And this is for 2 years. All you'll be paying is 70 rupees a day. So think about it. We typically recommend 24-month program to students in class 9 to 11 because it's a 2-year long journey. And if you're a dropper or a long-term student, we recommend that you go with a 12-month subscription, which is going to cost you only 34,650, which is like 2,888 per month, less than 2,900. This is about plus subscription. And and this is about plus subscription. We have something even beyond plus subscription. That's going to be an iconic subscription. And what do you get on iconic subscription? Personal coaching, mentoring from IITians and NITians who have previously cleared IITs and IIT JEE Mains and Advanced, and they'll be guiding you through this process and aiding you with the strategies and the workshops to make it happen. They will be, mentoring you throughout your journey. And not only that, students, you'll also get access to study planner, more and more like test analysis, etc. on iconic subscription. And coming to the pricing of iconic subscription, it's also pretty reasonable. All it would cost you is 58,500 if you go for a 12-month subscription, and if you go for a 24-month subscription, which is typically recommended for students in 9 to 11 plus, you'd get it at a price of 90,000 only. And be sure to apply Murli Live code so that you can get to this price points and avail best discount, be it on iconic subscription or plus subscription. You will be able to avail best discounts by applying Murli Live code. Yes, and also 6 months, 12 months and 24 months program. So yes, hi. So let's get into this amazing topic, guys. So we'll be having a look at a visualization. So think about it. So you have two masses. One is this large mass. For now, let's assume this to be so large that this guy does not have any mass. The one on which I'm shortly ticking. So now think about it. If I like the one on which I put the tick mark. Now think about it. This mass at this distance r from the capital mass m, the one in orange color. So is it going to attract the mass? Yes, of course. There is going to be some negative potential, right? Negative potential means the system will do the work and attract it towards it. Okay. Just like this is the same scenario as where you have a flat surface, like on Earth, like one you're watching right now. Of course, Earth is not flat, but let's say you're dropping like a ball or something. It comes down. Similarly, this mass is being attracted. Okay, so if you leave this mass, it will try to get attracted to this large mass. Since this mass is large, both are going to move towards each other, but the movement of that large mass m is going to be negligible. The test mass m naught is not going to accelerate the large mass m, since the force applied on both are equal. Now in this case, let's say I have this test mass. Just imagine a situation where there is only Earth, no other planets, no other objects, and you are the only person, or a test mass is the only person. So you need to carry this test mass from a height or from the surface of the Earth to a large distance, to this large distance from this point P to a very large distance, infinity. Right? So how do you calculate the work done in this case? And assume this to be also a point mass. Now this appears to be like a sphere. Don't take it as a sphere. For now, just take it as a point mass, but a very heavy point mass. So this is going to be very heavy point mass. Hi Abhiram. Hi. Is this time enough for preparing? Good question. So Abhiram is coming up with a really interesting question. Is this time enough for preparing for your JEE Mains? Assuming that you are going to start today. And if you are going to only start today, start it today. Don't wait for any delays. And given that in the present situation you can do it, but plan accordingly. Maybe you want to try for the second attempt, third attempt, like however you are more comfortable with. Maybe not necessarily aim for the first attempt, but give your fullest even in the first attempt. Learn from your mistakes and improve upon it the next time. And definitely don't do that you're not giving the first attempt, because one, you'll be getting accustomed to the exam environment, like how to give this JEE Mains, etc. You'll be understanding the exam pattern. So there are many advantages of giving this exam. Do not just say that I'm only half prepared or 10% prepared, I'm not going to give this exam, assuming that you'll be like 60-70% prepared by the end of the next exam. So make sure you're giving this exam, but you're preparing for the next one, but move very strategically. It's totally possible. Not in the Feb, but maybe if you're just beginning now, maybe after 4 to 5 months, 6 months, you can do it. All right. So now assume this to be a point mass, this large mass and this heavy mass, heavy point mass. So this is like not just a point mass, but a heavy point mass, and you have a test mass. Okay. If you remember, we said that we don't consider, this test mass to have any such huge or large field that it affects the, the large mass M. So in a way, only what you're trying to do, you're trying to pull these 2 point objects apart, from each other until infinity distance. So it's like you're carrying an object from Earth. Hi Muttu, hi Srinivasa, hi Muttunuru Srinivasa, hi. Hi everyone, good evening. Absolutely, you're welcome, Abhiram. Yep. So now think about it. You have an object on Earth and it's at a height h, or it's on the surface. Okay. Now you're trying to carry this object from Earth up until some point in the space such that the distance between this point mass and this Earth is so large. So some work has to be done because it's an attractive force. You will be working against the attractive force. So there would be an attractive force in this direction. So if you are going to carry it, or let's say you are going to move it without disturbing the system, then you need to be also applying some force, which is going to be in the exactly opposite direction, right? You will be applying some force, and you will slowly carrying it until infinity, and you'll be making sure this mass is at infinite distance. So this work done in doing this process from this distance r to infinity per unit mass is known as the potential of that large mass at point P. Okay. Now think about it. You're doing this work, of course, from carrying from this distance r to infinity. There exists some potential. There exists some potential at that point P, where this test mass was present, right? There exists some potential at this point P where the test mass was present. Hence, you had to do the work, right? If it was all zero potential, or like zero field or constant potential, you would not be doing work. Okay, one of the things that you want to remember, if there is a constant potential or zero potential, even zero potential, it's possible that you're doing a little bit of work, but constant potential, you're not doing any work. Okay. So if there is, so how do we define, gravitational potential? We say that it is the work done in carrying that small test mass to infinity distance, and you divide it by that m naught. It's actually the work done per unit mass in carrying the test mass from a distance from this heavy point mass m to an infinity distance. That's it. That is known as your gravitational potential, right? That's it. All right, let's get into it. So now we have defined it. It's basically the work done in carrying this mass, work done per unit mass in carrying this mass up until infinity distance. Now, how do we do this? As I told you, we need to be applying a force to make it happen, right? And this force has to be equal or little more than the force that you are getting due to attraction. Okay, this mass is being attracted. There is a force in this direction, which is nothing but gravitational force Fg, and similarly you'll be giving some Fg plus F delta G, and delta Fg to carry it that way. Let's take it to be negligible, and let's calculate. Now, if you have noticed, at each of the point, the force is changing. Let's say this green color object is over here, this test mass is over here. Now what is happening? The distance is changing, hence the force will be changing. So it's varying force case. What we need to do, we need to take for each small distances that you move, let's say dr distance that you have moved, you will be calculating the work done for that each dr elemental distance. So what is the best carrier option after engineering, civils and law? Even civil or law, it depends totally what you want to do. Best carrier option is according to you, students. Wherever you are passionate, whatever you are passionate about, and wherever your heart lies, that is going to be the most interesting thing or the most appropriate thing. Really good question. So according to me, best career after engineering would be to become an engineer. or maybe like a management personnel, but according to you it would be different. It depends upon your ambition, what you're trying to do, etc., and how you're trying to like look at this engineering degree as is it a value add for your higher education, or is this going to be like the thing that you want to do. You want to become a computer scientist, you want to become an electrical engineer, you want to become a mechanical engineer, you want to build buildings, you want to become a civil engineer. Yes, then this is the thing that you want to do just after engineering. Maybe do an MS or not do even an MS or MTech, then pursue your career in this. Otherwise, it totally depends upon your ambition, your your vision, your kind of thing that you love to do. More importantly, you should be doing something throughout your life that you really like to do, else it would really become a very tough task to deal with. Something that should be interesting, that something that you should be passionate about, else it's going to be like very tough. Not very tough, it will be just a regular life, mundane lifestyle. You'll be just going through regular stuffs. Maybe you will be enjoying stuffs. It depends totally. I wouldn't say that way, but this is just for starters. Once you get into any field, it may become interesting. There is no such thing as it does not become interesting, but at this time you have to think this way, that what you are passionate about. Okay, all right. So let's say now this mass is at a distance r from here, small r. What is the force at this point? I believe you got your answer. So what is the force at this point? It's going to be gm by r square. Which force? The force that you are applying. The force that you are applying, right? Not that it's the same as the gravitational force, but the negative of the gravitational force, if you're noticing. Okay, if you put an r cap, that would be the most appropriate thing to do, without a negative sign, without like a vectorial sign. Negative sign does not make without a vector indication, negative sign does not make any sense. But yes, so now what you're supposed to do, you are also supposed to apply this like minus fg force in this direction, right? And how much distance you're moving? dr, since it's a variable force. So to calculate the work done, what would you do? You'd integrate it over dr from r to infinity. You are welcome, Srinivasa, right? You're definitely welcome. Just keep learning, guys. It does not matter, like what anyone says. Wherever you are more interested in learning, just keep learning. That's all matters, right? Now let's come to this point. Just a moment. So I think this r has disappeared. Just let me quickly redraw this r, because I wanted to draw this r in red color. Right. So the distance. This is the point mass. This is not a sphere. Just because it's large, it's not a sphere. I've just kept it as large because to indicate it's a large mass, heavy mass. Okay. That's the reason we have it in that huge size, right? And now what are the forces? As you know, there is a gravitational pull all the time, even in this direction, even in this direction. So this should be minus fg. I hope this thing is something that you understood. Now to calculate the work done, what you would be doing? So external work is exactly going to be this. External work is going to be integration of Fr, small distance dr moved from this place, and where you're doing this work from 0 to, okay, there should be an m naught. Okay, this is force, this is not field. From from r to infinity. Let me quickly correct this point. R to infinity, right? So what are we doing? We are moving this mass with the same force as gravitational force, which is nothing but gmm naught by r square, same magnitude but in the opposite direction. Okay, in the opposite direction. Now the thing is, how much distance you are moving for each of them, because it's a variable force, it's dr distance. Now you would be integrating it from r to r was the initial distance, right? This was the initial distance, and then it went to infinity. Okay, that's it. Now we need to calculate it and move on. We are going to integrate it. That's it, students. That's all. Probably most of you know how to do this. It's not at all a big deal. Okay, so what do we have? We have something like this. I'm integrating the same thing that has appeared earlier, but just substituting the value of Fr, which is nothing but Gm, capital M, into test mass m0 divided by r square dr. R to infinity. R to infinity, right? If you integrate this, what would you get? Gm and m0 are constant. You can just take them out. Now, inside it, you would have what? Minus 1 by r. Right? 1 by r square integration. It's minus 1 by r. This is from r to infinity. Okay. Now, if you do this, what would you get? You would get something like this. Gm m0 into plus r or minus r. It will be plus r. Right? Minus 1 by infinity minus of minus 1 by r, which is going to be plus of r. Right? This minus of r, minus of minus 1 by r, 1 by infinity is 0. Simply it is your Srinivas. Absolutely. Stay tuned. And now we have done this. Now we have to calculate what is the total work done in this process of carrying it to P to infinity. Right? That's the last thing that we are going to do. And then what is the external work done? If you just put this equation, you substitute everything, what would you get? G m m0 divided by r. It's all positive up until. Okay, now here is a twist. We would define, okay, it's per unit mass, but what are we going to calculate actually? Potential difference. Okay, that was the definition, but what are we actually calculating? Potential difference. Recall this potential difference, potential at this point to be Vp and at infinity to be V infinity. The twist is, it says that at infinite distance, you don't have to do any work to move the charge. There exists no force. So the potential is going to be 0. Okay, we have to find out what is the potential at the point P. Okay, that is it. At infinity it's 0 because no force exists once this mass has gone to infinity. Is there any force? No. It's out of the picture. It's as if the mass does not exist. So no potential, no work is being done. Very minimal work is being done. Alright. So now what did we define potential to be? Now in this case we'll be talking about this potential difference, not exactly potential. Right? And how do we generally define this? Is we say that V final minus V initial is equal to work external divided by unit mass. This was the definition. We are going just by the definition. Divided by that unit mass. We are calculating the potential due to capital M, this heavy mass, right? Don't get confused in this point. It's always about that heavy mass. It's not about the test mass. We are not even worried about the test mass. Okay, if you calculate for test mass, you will get that. Okay, that's not a big deal. It's divided by M0. But anyway, do remember one more important thing. Okay, this may not come typically in this kind of simple questions. So what happens is, hi Anjali, absolutely. So the thing is, if I asked you what is the work done, external work done in moving, okay, let's say there is a different scenario. Okay, up until now this is clear. Now we will do a thing, we'll derive the expression for potential at point P. Before that, now think about it this way. Instead of moving test mass to infinity, you are moving this capital M to infinity. Let it be test mass, let it be a small mass. What is the work done in this case? It's going to be the same. Do remember this point, do note down this point, do understand this point. Even if I am saying that there is a small mass, test mass, and there is a large mass, capital M, like point mass in this case. If I am moving this point mass even to infinity and keeping this, M naught intact, by applying some force, the force is the same with distance. Hence, the work done is also the same. Okay. So, the work done extra, because this, now think about a question, this will be coming up soon. I will be explaining you with the questions as well. So, think about a question where they have given you a complicated structure, but you are able to find out the potential, the complicated structure. Maybe not of the point mass due to the point mass on the complicated structure, but due to the complicated structure on the point mass. Then calculate the work done and just say that this is the same work done. Okay, I'll come to that point, you'll understand it. Just note it down. What you need to understand is, even if I move that heavy mass, it's going to be the same work done. Even if I'm going to move this heavy mass from distance or from the test mass, small test mass to infinity, it's the same work done. Okay, so basically it's as if you are moving capital M and this test mass, the small mass, infinity distance apart. Either one of them would work. Okay, now let's move on to the next thing. See, Anjali, good. The question again came up. See, this is actually a point mass. What is this? This is a point mass. This is distance between the point masses. I've got this heavy mass to look, big because it's a heavy mass. As such, this is also, like of a tiny, a size. It does not have, a radius or something. You can take the radius to be nearly unit or nearly zero something. Everything is concentrated inside a small space. Okay, clear? It's basically a point mass. It's not a large mass. All right. So what is V final, V infinity? And what is V initial? We don't know. It's Vp. And we need to calculate this. And we notice in this expression that we have written, per unit mass will be cancelling out m naught and m naught. Okay. M naught and m naught. This would be Gm by R. Potential due to which mass? Potential due to the heavy mass. Going to be Gm by R. Okay. Amazing. So yes, if you simplify this equation, what is this? V infinity is 0. So this is going to be what? 0 minus of some Vp. So basically minus Vp. So that's the reason you are getting a negative sign. Clear? I hope this is clear. Let me again condense down this equation on the next page as well, but the expression is given in the next page. So from the earlier one, we can say that minus Vp is equal to Gm by R, which is the potential of this. Potential due to this mass. Going to negative reason, it's an attractive force. Easy? Okay, good question. Really good question. So yeah, one of the students asked a really amazing, brilliant question. So we have been studying, yes, I thought this question should come up, else I was going to explain this. So let's take a blank screen. Just a moment. That's really good question. Okay. So, her question is, So we always talk, you know, about at a distance h or at a height h, we say that the potential is mgh, right? So what is this mgh actually? It's basically saying this is the potential. It's potential or potential energy. Think about it carefully. mgh in this mass m is going to be potential or potential energy. It's going to be actually potential energy. That way, per unit mass, gh should be the potential. We're just approximating it all per a different definition, etc. This is potential energy. For students who don't know potential energy, you can just just relax it back and relax, because we'll be soon moving into potential energy concept. We haven't got into the potential energy concept yet. So this is the common kind of doubt everyone has. So we used to say this is mgh. If I'm going to derive it, I'm going to get a different value of g. And if I substitute it, the potential according to this is potential energy, which is going to be mgh. That means potential is going to be potential due to whom? Earth. It's going to be gh at this height per unit mass. Okay, yeah. Now the question arises, if it is gh at this point, is this gh correct? It's approximately fine. Even this potential energy term is approximately fine, because as you move to some height, it's a very small distance. It's a very tiny distance. So you say it is fine. This is, if you derive it exactly, it's altogether a different term. If you take g to be certain height, what is g happening at certain height? You say that gm by r plus h whole square. Okay, m of earth into r plus h of whole square. What we say, isn't it? And we further we can say this as g into r square divided by r plus h whole square. So this is g on surface. Then we do this, we say this, this is what is happening. And then if you remember, we approximated saying that the distance is very small, right? So if you multiply this g with h, it's still not correct, isn't it? Right? It's still not correct, but we are approximating it to the most extent. Yeah, gh. H is very small, exactly. You can further try to simplify this. Possibly you want to try it out later, because this is going to consume time. It's definitely a very interesting question. If you remember, we used to take it on the denominator, and we used to say this is going to be 1 divided by, I'm just speaking this, 1 divided by 1 plus h by r to the power minus 2. So we would be writing down this like this. We can write it down this way, right? And we further approximated something, like saying that, okay, this is fine. This can be approximated to gs into 1 minus of 2h. Okay, but this is not the expression that we are getting. If you multiply this with h, this is what your expression should be. We are not getting it. That's basically an approximation that we have been dealing, because the distance is so small, right? Just put this distance to be too small. It's fine. Say h is approximately or let's say h by r is approximately equal to 0. Very small distance, negligible, some delta. That's it. So this would become just gs. Now multiply this gs with h, you get the potential. Now the potential becomes what? G into h, right? Potential. But there is again a thing that you need to notice. This is again, whatever expression I'm writing is again not the most appropriate expression, because we are not accounting the change in the force, right? There's also change in the force, hence we should have been logically integrating this term for dh, dh. But that's not practical to do. Even this itself is an approximation, hence we can directly say this. Okay, that means potential energy multiplied with mass, you are going to get potential energy. Simple? Yeah, exactly. Binomial expression. Not at all tough, guys. Not at all tough. Simple. Right? This is an approximation. You don't need to really apply this this form of expression. This is for what we are doing. Why we are doing this? We are going to deal with like planetary motions, satellite motions. We are going to deal with astronomical bodies. So in that case, we apply them not for an object that has been just lifted off the earth. For just lifted off the earth, we will be saying potential energy is mgh. Now let's come to a very interesting and an important, definitely important. Why am I saying this important? Maybe questions haven't come from here until now, but recently the questions have started popping in your exam from this particular concept. That means there are high possibilities you'll start getting the questions from this part of the thing that we are going to do. This should be clear, students. This is what should be in your mind. Given for a point mass, of course we will be definitely be solving for different kind of distributed masses. It's going to change, but it's simple. And do understand this thing so that in future your electrostatics becomes very easy. So we say mgh only in work energy power, not in gravitation. Yeah, correct. We say this in basically your other part of the mechanics, work power, work energy power. And there too, what we have calculated is saying that at the center of earth you're moving that object, which is still not practical. You're moving from the surface, again from r to r minus h. You subtract it, you will get the same thing, students. Don't worry about it at all. Really, that's simple. Alright, don't worry, don't confuse this thing with the mgh. That mgh is the same thing that we have approximated. And the other thing is, students, the other thing is, this is for large bodies, large masses, like celestial bodies, in space, satellites, etc. Right? Then we are not going to use mgh. Mgh is does not totally make any sense. Right? In this thing, we have been observing, your questions will be something like this. You have moved to some part of the world, like from equator to your north pole or something. And then what is the change in the gravitational acceleration that you're experiencing? And how much time this ball is going to take to drop from that height at pole and at, like your equator, given that the radius at equator is this much, or the rotational speed is so much, or something like you have two planets or 2 point masses or system of point masses or a ring, something like that. Okay, you're absolutely welcome. So there is an analogy. Yes, actually there is a thing, students. There is whatever Srinivasa is also saying is correct, whatever Abhiram is saying also correct. There is actually no connection between, conceptually there is no connection between your gravitation and your electrostatics. Conceptually they are two different things. Okay, but speaking about the kind of derivations or the kind of sums that we will be doing, they can be little similar when you compare gravitation to electrostatics. Electrostatics chapter is large, huge. There are so many concepts in them, dipole, etc., etc. There are like n number of concepts. In gravitation, there are very few concepts. Gravitation is comparatively a shorter chapter. And the other thing about electrostatics is, in electrostatics, whenever you are doing this for JEE, as long as it is JEE Mains, it is fine. But once you are thinking about JEE Advanced, right, you should be trying to perfect the basic mechanics to solve problem really well in your electrostatics. Because generally, what happens is in JEE Mains, it's really a good topic to score. When it comes to electrostatics, you get 2 questions, easy questions, and there you go. It's like a bliss many a times. And what happens is in JEE Advanced is that turns out to be a headache. Sometimes it may consume time. So that time you want to make sure you're perfect with mechanics as well during JEE Advanced. Generally in JEE Mains it does not happen. And as long as the analogy is concerned, right, the integration part, the calculation part, the kind of things that we'll be dealing with, little bit similar. Basically the mathematical part is similar, conceptually very different. Okay. Depends. Good question. Like Srinivasa has a really good question. So Srinivasa's question is something like this. He's asking me whether am I going to use this ever in my life? If I become a software engineer, am I going to like use these concepts in my life? Maybe, true. let's say you have become a computational scientist, like dealing with something like space sciences, etc. Maybe you're going to use this. Maybe you became an like an electromagnetics computational engineer. Somewhere nowadays the research is going on in this, right? Even there are positions in Intel, etc., where people are dealing with like nanotech based research, etc. You will be using these concepts. Your skill set is not just going to be coding, etc. Your skill set is also going to be related to knowing things around them. You are going to code, you are going to develop models. That is totally possible. It depends what kind of software engineer you are becoming ultimately. Let's say you're going to develop an app, probably not, but there are high chances you're dealing with some, you're working for some research institute, or you're working for as a PhD scholar, or you're working for some NASA, etc., developing models, or ISRO developing models. That time you may be using this model, you may be using this concept. And maybe you're working for a high-end R&D company where they are conducting continuously researches in this field, and don't trust me, like it always happens that people think this is not at all useful. There are companies that are doing research in this field. Okay, like many companies. There are government organizations that are doing research. There are institutes that are doing research, dedicated research institutes. It depends upon what you're trying to do in your life. Okay? Absolutely, you are welcome, Abhiram. Don't worry about it, Anjali. I'll be taking you through all the integration part. So as long as your physics is concerned, I believe integration, the kind of integration that you need, is not so complicated. We always are dealing with those things that are necessary for your exam in terms of mathematics or in terms of sums. So don't worry about the integration part. Integration is going to be, it's easy. First, believe that it's easy. Definitely it will become easy given that you practice. Okay. All right, students, now comes the question: how do I derive the relation between potential and gravitational field? Okay, if you remember, what was our potential at any point? I believe everyone's question is answered, so don't worry about integration and stuff, especially in this place. We will be like taking you through the necessary integrations necessary for solving problems around physics. So this is what we had. Forget this test mass for now. There is no test mass, only we are calculating a point P. Now the question arises, what is the gravitational relation between gravitational field? We'll be initially making use of this test mass. Like other than that, we don't need this test mass, right? And what did we say this to be? This is nothing but work external divided by m naught. If you are moving m naught to infinity, if you are moving m naught to infinity, this is when this is applicable. This is going to be negative sign, if you remember, because we did v infinity minus vp, so there would be a negative sign here as well. Okay. Now comes the question: how do we calculate? What is the like gravitational kind of field? So in this case, we can do a thing. We can say work external. Okay, just rearranging the terms. I'm saying that this is nothing but minus m naught into vp. Okay. Now, what is the work external? Work external is basically done against your gravitational force. The same thing we are going to state, and we are going to say this is what gravitational force, but we'll be having a positive sign dot dr. Right? So what is the force of interaction between them? G m naught. If you remember that, it's r square at this distance r. Right? That's it. That's all we need to know. But how do we used to write this? This is the initial Newton's law. And then how do we used to write this? We used to say this is nothing but m naught into E. Okay, m naught into E. But in this case, what are we doing? We are dealing with external thing. So we can write down this as plus E. It's actually minus E, but we'll be writing down this as plus E. So if you are taken the work done by the internal system, then you will be taking minus E. If you are going to calculate work done with respect to the external system, the field. So you are also applying a field in this case. Think about it, you are applying a field in the exact opposite direction, which is going to be plus E. Actually, it would have been minus E, minus E, minus over here. So now what you would be doing is you will be applying a plus E field dr, right? This is into m naught. Just a moment. Now let's do this. Forget this work external. This is good. This is going to look something like this. M naught VP. Very important, students. Not actually how it all comes, but most important thing would be solving problems around them. We are taking it as plus. Do remember that we already have a minus sign over here, because we are calculating due to work external. Opposite direction, you will be assuming as if there is an m naught E force, but in the positive x. Okay, m naught is constant, just cancel it out and differentiate on both sides. On this side you will be getting something like dVp, and on this side what you will be getting, just the integration will be removed. If you differentiate this, what would happen? The integration side would be removed. That's it. That's all is going to happen. You're integrating, you're differentiating, basically you are doing nothing. Okay, integration is the exact opposite thing of differentiation. So E is going to be how much? Minus dVp by dr. Very important is this. And there is even one more important thing. I'll come to this part. And what is the direction? There is a direction associated with this. In this case, it might be like x cap, but generally think about it. We state it as r cap as long as it is r. Around the space, we state it as r cap. That's it. That's it. That's all you need to know. That's it. Now coming to the next part, right? R cap is because of radial distances. We say that r cap. Now let's say you have an expression in x, y, z. Okay. Rather, your potential Vp is not expressed in terms of r, as in this case as well. You would be observing this. We have only moved it infinity along x direction. Right? It's quite possible that many times your potential is just, you have created an artificial potential, and this potential is just varying with respect to. It happens a lot in your electric field, but in your masses, I don't know how do they do that. I would say, Abhiram, as long as you have not covered the topic, yes. But if you have already done the topic, focus on revision, focus on PYQ session. PYQ session is totally for you students, so that you are able to understand not just the concepts. I'm also trying to quickly revise the concepts in those sessions, but also how do you solve problems in your exam, right? And I recommend also 11th class students attend PYQ session. There is a reason behind it. There is an easy way of solving questions. You can guess the answer, not guess, but conceptually guess the answer within few minutes in your exam. That's totally possible. Okay. Yeah, one shot, I would see there is a risk with one shot. There is an issue with one shot. You will never be able to cover your syllabus in one shot. One shot is like like a half-baked biscuit, like not even half-baked, like a quarter, 20% baked biscuits. Many a time depends totally upon how it is being done. Whether the one shot is being done in like several sessions, or important topics are being done in one shot. But generally it's a half-baked, not in half-quarter, less than that baked biscuits. So it's like kacha biscuits that you may think about. It's like raw biscuits. So sometimes not the best thing to do. Maybe sometimes it is, depending upon the topic, depending upon subject. But PYQ sessions as such will help you understand the logic behind it. Anyway, one shot sessions are being done by Rohit sir in terms of physics, I guess. So that way you can do the one shot sessions and other things. And PYQ sessions will also give you exposure in terms of like just like one shot. I wouldn't say it would be a one shot, it would be lengthier, but you'll understand the tricks. And one more thing you should be noticing in PYQ sessions, this is for 2021 aspirants, 2022 aspirants. You have your own way of going. You will be attending PYQ sessions to understand the logic, to understand the tricks. But 2021 aspirants, what you need to, or 2021 aspirants, the other thing that you need to observe is which is that part of the syllabus that is being frequently asked, and try to cover the concepts around them. For an example, a lot of questions are there just around your Gauss law, dipole in your electrostatics. Similarly, if you go to current and electricity, there will be only few things, some Kirchhoff law, some things around which most of your questions should be there. Still, that's still a raw bet, given that you are going to have 8 papers, altogether 8 papers. So that way, like 8 papers means not one of you, not actually now it's going to be even more, right? Yeah. It's going to be even more. So now think about it, you need to maintain perfection in each subject, students. As far as I'm guessing, if at all multiple sessions are happening, I'm not sure whether I haven't seen that yet. Depends totally upon your preparation, Abhiram. So whether you should be starting revision for 11th class at the moment, or whether you should be starting for, it's a very tough question. According to me, what you need to do is probably do those important topics, right? Like 12th class students, your objective should be completing those important topics. So if it's an XYZ, I believe you got your answer. If it's an XYZ, how are you going to deal with this? Students, focus on this thing. This is being nowadays asked very, very frequently in your exams. Be it electrostatics, be it your gravitation, very frequent question it has become. Even they are being asked in your JEE Advanced. Okay, so focus on this particular thing. So what would we be doing? We would be doing something like partial differentiation. Note it down. If you don't understand this, how this partial differentiation is done, you will have a lot of problems coming up. So just try to understand it, try to attend, try to maintain continuity, students. Maintaining continuity is very, very important. Trust me, maintaining continuity is so important. Okay, like now gravitation, you attended the first lecture on gravitational potential. You should be trying to attend all of these lectures, like next upcoming lectures. Don't miss them out. Even if you miss them out, try to make sure you're completing it after some time, or try to maintain the continuity for at least each individual topics. I've done a mistake. You're absolutely welcome. Abhiram, do a thing. Just watch the strategy session once that has been done earlier. During your I think 1 month ago or something, I've done a strategy session, keeping in mind that assuming that your exam would be happening in the month of Feb. I've given some strategies. You can start following the strategy even now. Okay. All right. Let's come to this part. What have I done? So now the thing is, your potential is not in terms of R, but rather it is given some X, Y, Z. It can be something like K into X, Y, Z. Your potential could be given in your exam as K into X, Y, Z. Or they may ask you to derive the field, or they will give you the field and they will ask you to derive the potential. Now, how do you derive this? You will be doing a partial differentiation. You will be saying if it's minus dV by dr r cap can be written as minus dV by dx x cap, dV by dy y cap, dV by dz z cap. It's actually known as dou. Okay, this all terms are known as dou because we will be doing partial differentiation. So we say it is dou v by dou x x cap, dou v by dou y cap, dou v by dou z cap. Just you differentiate it with respect to x, with respect to y, with respect to z. So what is happening over here is just a small explanation, especially for 11th class students, right? You are welcome to, absolutely. See, dou v by dou x means x is the only variable thing, y and z are constant. Similarly, dou v by dou v means in this thing x and z are constant, What is variable? You know, only y is variable, right? Okay, we'll take an example. We'll take this example and solve it. We'll do it in detail later, but just try to understand this thing. Let's say your potential is given something like this. Your potential expression is given something like this, and you're asked to derive. Okay, this is in terms of x, y, z, right? You would not be anymore making use of this one, but rather the new expression that we are going to derive. Okay, how do we partially differentiate it, and then we will express in terms of electric field. Basically, it's this is the electric field. What is this? This is nothing but your electric field, isn't it? It's the same thing. Okay, we understood the partial differentiation part. This is the electric field. So let's do a thing. Let's derive the electric field. So this is k is constant, k x y z. K x y z, k is constant. What this would become? What did I say? Just keep a negative sign outside. Let me use the blue color. Just a moment. Complete this quickly. We have a class upcoming on your PYQs. I'm going to just write down the same partial differentiation expression. Now just keep noticing, students. Minus, what do I mean by dou v by dou x? What does this yield? This yields, I'm just calculating dou v by dou x. Forget the rest of the things. Okay, let's do it step by step. Okay, it wouldn't take much time. Let's do it, and maybe later on we can look at the problem. Okay, partial differentiation around x is going to give you what? In this case, x is the only variable thing, so you'll take out y and z. K, y, z, k is anyway constant, y and z, and you'll say this nothing but dou x by dou x. Basically this one. This is going to be k y z. K y z what? X cap. Right? In your expression, it's going to be x cap. Let's do it for each and every one of them. Okay. So we add, potential is equal to k into x y z. Okay. What did I say? Dou v by dou x came out to be something like minus. Okay, we are not taking the minus sign. We are just calculating the potential partial differentiation with respect to x. And this we got to be something like k into yz. And what about dou v by dou y? Again the same thing. Write down the expression x, y, and z differentiated with respect to y. This is going to be k, x and z are constant. In this case, y is the variable thing. Now this is going to be kxz. Now dou v by dou z. What does it give you? Dou of k into x, y, z, which is the constant term. Constant terms are, for this partial differentiation, what is the constant term? It's going to be k. Sorry guys, it's dou v by dou z. I wrote it as dou y. Let me correct this. So what is the constant term? Constant terms are x and y. K, x and y. K is anyway constant, even if you're doing direct differentiation, not a partial differentiation. This is going to be dou z by dou z. This is going to be just k, x, y. Now notice the amazing thing over here. This is how you may get some problems around this. So if I'm going to ask you electric field, how you are going to write it down? See, let me erase everything. Now you need to note down this expression, students. Okay, we have this anyway in the next page. What is our electric field? Dou v by dou r cap, but it's in xyz, so we are going to write it down as minus dv by dr r cap. This is going to be minus dou v by dou x cap, plus of dou v by dou y cap, plus of dou v by dou z cap. Minus is outside, common. Okay, you understood this part. What are we going to do is, we are basically going to say, forget everything. If this existed in this way, we would no more be using this. Only in terms of R this is applicable. Okay, if it's given in terms of X, Y, Z, this is how you'd be writing. Okay, we are going to do the same thing. Now, what is electric field? Electric field was minus of dou V by dou X, X cap, K, Y, Z. It's varying with Y and Z. Electric field is different for different Y and Z. In which direction? In your X cap direction. Easy? This is going to be, the next one is going to be what? The next one is going to be K into XZ. Along Y direction, electric field along Y direction, sorry, gravitational field along Y direction is going to be its gravitational field. Okay, gravitational field along Y direction is going to vary with X and Z. For different X and different Z, for even different combinations of X and Z, you'll be having different, gravitational field, right? And there we go. We have another term coming up, that would be our Z term, right? Z, what do we have? K of xy. It's going to vary with X and Y respect to Z cap. It's basically negative. You take out that K will be common, etc. You can do that thing, right? So you can take out K common, etc. You can do that later. We'll do it during our sum. We will have a similar sum in the upcoming session. And you can calculate the field at some x, y, z, right? You can calculate the gravitational acceleration at some x, y, z. You can calculate the gravitational field at some x, y, z. This is how you would do it. I hope this is clear. But you can just rewind and watch it again after the class gets over, right? So yes, these are the two important concepts. One, how did we come to the gravitational potential? And the other one was what? How did we derive the relation between your gravitational potential and your gravitational field in terms of r cap and in terms of x, y, z, x cap, y cap, z. I hope this is clear. This is easy. This is clear. This is pretty easy. Really, really easy. That's it. Work done per unit mass in carrying the distance from a distance r to infinity, from a mass m at a distance. That's it. That's all. We'll have more interesting problems coming up with regard to gravitational potential. Stay tuned. We have many easy, interesting, like mains kind of mains type of problem, advanced type of problem around this. So stay tuned. So many interesting problems are coming up, right? We will have different kind of bodies that we'll be dealing with. We need to apply something different in them. Okay, basically understanding the concept is the key. Math is not the key, so don't worry about the math. We will have so many amazing things to do on gravity. Gravitational potential work done. Then we'll be moving into your gravitational potential energy, that mgh, and then we will be getting into even more interesting things like your satellites, etc. This topic is very interesting, especially if you love space sciences, etc. You'll be trying to guess many things in life. Definitely a very interesting thing. But that being said, students, we are going to have a free special class coming Sunday and also Monday on what? Vectors. We have already completed how many? We have completed 4 A to Z this thing like lectures. 4 sessions have been already completed. We are going to have part 5 and part 6 on coming Sunday and Monday. What time? From 10 a.m. to 12:30 p.m. Don't miss it out. It's a free of cost special class on your Unacademy learning app. Okay, this kind of the revision session. It's kind of the starter session. If it's your starter session, make sure you're also completing 4 parts and you can understand vectors from really like an amazing physics perspective, and you'll love it. In fact, we are going to solve many problems around vectors that the type of problems and vectors that have been asked in your exam. but probably something it's basically vectors only, but around cardinal points, etc., where your questions have been asked. Vectors is a very key part of your physics, or even it has a good weightage in mathematics. So do and try to cover this vectors all these 6 sessions, because with the 6th session you'll be probably completing vectors. But that being said, 4 sessions are also very important to understand it from physics perspective. If you have any confusion around vectors, to complete it. These are those 6 lectures that you have to attend to understand vectors. Probably you'll get questions sometimes, probably you'll get questions in mathematics, etc. Definitely you will get an application of vectors. We'll be dealing with application of vectors. We'll be having a look at PYQs around vectors, application of vectors, etc. in this A to Z series. Yes, these are all free of cost A to Z series. And not only that, students, we have already completed units, dimensions and measurements A to Z series. Again, 2021, 2022 aspirants, do not miss out this topic. This is an easy topic for your JEE preparation. All you have to do is attend this 4+1. There is an additional, like a problem practice or a DPP session on units, dimensions and measurements that I have completed on your Unacademy learning app. Again, I told you A to Z series are on Unacademy learning app generally. So try to complete them. We have completed everything around your units, dimensions and measurements. This includes units based problem, dimension analysis of important quantities. 2022 aspirants, do not worry about how these things are expressed. I have given an explanation for everything, but maybe not the in-depth explanation. Anyway, you'll deal with magnetic field, electric fields, etc. in your second year topic. But yes, pretty much every explanation has been given for you, 2021 aspirants and 2022 aspirants, so that you understand it. And 2021 aspirants, do not ignore this topic, because it's a very short topic. All you have to attend is 5 sessions to maintain the completeness in units, dimensions and measurements. Yes, it takes less time. It's an easy one. Also in your exam, it's an easy one, and you definitely get 1 question every year in your exams, like be it mains or advanced. You wouldn't notice a paper without units, dimensions and measurement problem, that too easy problem. So definitely worth completing. Complete these 5 sessions, your preparation around units, dimensions and measurements will be complete. And how do you get live notifications on this A to Z sessions and also on your YouTube sessions? You may want to download Telegram app. Definitely do download Telegram app, and more importantly, get onto our Telegram channel. So we have a Telegram channel. Our JEE English team has a Telegram channel on which we keep posted you with important updates regarding your exams, regarding your syllabus, also any special sessions happening on Unacademy learning app, and daily lectures that you are watching right now. So just click on to this link. This is available in the description box below, and first of all, download this Telegram app, and also do definitely download Unacademy learning app. I'll tell you why. Do download Telegram app and then click on to this link to get this live notifications and all the information on the exam. Yes, do definitely do that, and we also keep you posted the DPPs, etc. on your Telegram channel, JEE English Telegram channel, guys. Yes. And not only that, yes, do download Unacademy learning app. Why you have to download Unacademy learning app, and how do you download Unacademy learning app? First of all, type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app. Just click on this link and click on this install button, the most downloaded education app in India. And let me tell you something amazing about Unacademy learning app, guys. Students, once you have an Unacademy learning app and you start following me, you will get live notifications on these A to Z sessions, right? You will be getting live notifications on these A to Z sessions once you follow me. And yes, live notifications, and you can attend these classes from anywhere. These are all free of cost classes. Of course, we have completed many more things. You can check out my profile and you can attend those classes for free of cost. Not only that, there are many educators conducting free of cost classes on your Unacademy learning app. So do download it and follow your favorite educators to get live notifications. And students, one more important thing, if you have Unacademy learning app, you can also get access to free of cost quizzes, etc. So yes, there are quizzes that are happening every now and then, national level quizzes, which you can attend using your Unacademy learning app. And students, also one more thing, you can attend Unacademy race, Unacademy combat, and many more interesting things once you have Unacademy learning app. So do download it. What is this Unacademy race? It's a rank accelerator competitive exam for 10th and 11th class students. And if you attend this a competition or a competitive exam, whatever you'd like to call it, on this coming 19th of December, you will stand a chance to win scholarships, free subscription, etc. And students, when does it happen? It is going to happen on 19th of December. And from what time? From 12 to 3 p.m. for 10th class students, and definitely everyone try to attend it. And for 11th class students, it's from 3 to 6 p.m. on 19th of December. And guys, the most competitive gamified IIT JEE battle ever, Unacademy Combat, is going to happen again on 20th of December. So enroll today with Murli Live Code. I need not tell you what it is. It's that, gamified and competitive IIT JEE battle where you can stand chances to win lots of rewards. This includes hundreds of Amazon vouchers that are going to be distributed that day, and as well as MacBook Air and Apple iPod and more and more. So do apply Murli Live Code while you unlock this, and be sure to attend it on 20th of December. And that being said, students, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, we have the best one for you. It's a Champions tool where you get to attend daily interactive live classes with the best educators across the nation. Yes, we have aggregated all the best educators for your JEE Mains and JEE Advanced preparation on your Unacademy subscription platform. And that too, you'll be attending these classes on a very interactive and attractive platform with polls and leaderboards, so that your learning becomes gamified and interesting. And guys, not only that, the amazing thing about Unacademy subscription is you also get access to test series and analysis. This way you'll be able to assess your mistakes and improve upon them. And students, one more important thing about Unacademy subscription programs are they are well-structured program where you would get access to live doubt clearing classes with the best educators across the nation. Every program would have a doubt clearing session attached to it. Every 4th session, in fact, is going to be a doubt clearing session, and every Unacademy subscription programs also come with bunch of quizzes and mega quiz. And now the thing is, how do you avail the Unacademy subscription? You need to download Unacademy Learning app, or you can attend, or you can do that from website as well. And if you're downloading Unacademy Learning app and logging in, just click on that left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and hit on this get subscription button. And the other beauty of Unacademy subscription is all you have to get is one subscription. You'll get access to both JEE Mains and JEE Advanced program at one cost, and to as many programs as you would like. And yes, coming to the price part, Unacademy subscription is also quite reasonable. It comes at a price of less than 70 rupees a day. All you have to pay is 70 rupees a day for a 24-month program, students. Yes, all you have to pay is 70 rupees a day. And how do you get to this price point? You need to apply Murli Live Code. And yes, this is definitely going to be the best discount code that you are going to apply on Unacademy subscription platform. And coming to the payment parts, we do have two interesting payment options for you. One is pay in parts, where you can split your payments into multiple parts and you don't have to go through the hassle of paying all the fee at once. And we do also have access to no cost EMI, where you can again split your payments into multiple parts without paying any interest on your easy monthly installments. So these two payment options typically take away the hassle of paying all the fee at once. We do also have access to debit card, credit card, UPI, etc. on our platform. If you would like to use them, you can also make use of them. And droppers and long-term students, we typically recommend, as you know, that you go for a 12-month program. So what do we have for droppers, long-term students, etc. on Unacademy subscription platform? Students, one day at a pricing of less than 2,900, you can get this 12-month subscription where you can attend classes from the best educators across the nation. And moreover, we have droppers batch, national level test series going on, micro courses going on. That way you can maintain completeness for your JEE Mains and JEE Advanced preparation. And yes, of course, this is less than 2,900, and this is after discount. So make sure you do not miss out the discount coupon while purchasing Unacademy subscription. So apply Murli Live Code and get the best discount on this amazing complete package for your JEE Mains and JEE Advanced preparation. And we do have something also known as iconic subscription. So whatever we have discussed until now is all about your plus subscription. We do have an iconic subscription in which you get all the features of plus. Along with that, you will also get access to IITians and NITians who will be giving personal coaching on your preparation, personal coaching, strategy sessions, workshops, and also you'll get personal study planner, etc. So think about it, you will be getting access to IITians and NITians who will be guiding you through this process who will be helping you in this journey, who will be mentoring you in this journey. They have previously done it. They know the path to success and they know what are the mistakes they have done. They will be able to probably help you with those as well. So yes, if you can afford it, it's going to be one of the best things for your JEE preparation, and a 12-month subscription is going to cost you only 58,500 and 24-month subscription is going to cost you 90,000 only, right? And that is for 2 years. So it's for 1 year, it's going to be 45,000. And do not forget to apply Muralidharan code to get the best discount on your subscription purchases, be it Iconic Plus 6 months, 12 months, or 24 months students. And now our team, JEE English team, is also on Iconic subscription, and we can take your JEE preparation to the next level with our expert guidelines, workshops, and our kind of guidance. You would be able to do that. And yes, what do we have on our team? We have IITians, IITians who have cracked IITs with flying colors, NITians. We have also head of coaching institutes on our team. So it's a complete team for your JEE preparation. If you'd like to prepare in English, if you prefer to prepare in English or any other language, that's available on our Iconic subscription, and you can prepare now in English with our team, or even Hindi, English, etc. Hindi, Telugu, Tamil, like whichever language you prefer. And yes, students, do not forget to like and share this video. Definitely do share this video with your friends, because it's a free of cost initiative in Unacademy, where you are getting full length, free of cost, high quality lectures for your JEE Mains and JEE Advanced preparation. So do share it on your social media, Facebook, WhatsApp, Telegram channel, like Twitter, etc., etc. Make sure you have your friends also on this channel, and they are attending lectures regularly. And do not forget to also like the video, and do not forget to click on that subscribe button and bell notification, because you will be getting live notifications on the classes happening every day. And students, that being said, do remember that, do keep smiling, work hard and also smart for your success. Try to attend the PYQ session. Do attend the PYQ session tonight at in next 10 minutes. That is going to be at 7:30. And I will live with the PYQ session. And in this PYQ session, we'll be not only discussing the concepts, but also the techniques, the easy tricks. If at all there is any, there might be some problems where necessarily you cannot apply the tricks, but still there might be method of substitution, etc. We will figure out everything, how to work that problem out in within few minutes, like 30-40 seconds. How do we guess given any problem using concepts and also using some mathematics, right? So do attend that and work hard and smart to achieve your success. Plan accordingly. If you're a 2021 aspirant, do things do things strategically. Take a smart path for your preparation. It's not always about hard work. It's not always about hard work, but it's also about hard work. That does not mean you're not going to work hard. You should be working hard. As much hard you're working in a smarter way, you're increasing your probability, or increasing your chances of getting into better IITs and NITs. So make sure you're working smart and hard, and do share this video, do like this video, do share it with your friends, because acquiring knowledge of course helps you in growing yourself. But if you distribute it, if you share it with your friends, that's going to help them as well, and you can brainstorm with them, and you can double and triple your knowledge. So do definitely share this video. See you in the next class at 7:30 p.m. with the PYQ session. Be sure to attend each and every PYQ session to get a detailed understanding of the techniques as well. See you today at 7:30 p.m. Bye bye. Take care. Stay safe. Bye bye.